Hello, hello everyone. A very good evening to everyone watching me right now. Am I audible and am I clearly visible? If you can just confirm in the chat section once. Okay, cool. So, in our today's class, we'll be revising current electricity. We'll be continuing with our current electricity, the remaining chapter, as well as we'll also be doing some PYQs, similar to what we did in our yesterday's session, right? So before beginning today's class, there is an initiative which is being run for you people right now who are preparing for your Re-NEET 2026 examination, and you're going to write your exam on 21st of June. And this is a completely free initiative. You don't have to pay anything at all to join this, right? So there is a Re-NEET 2026 Reloaded crash course for you, and if you scroll down on this page, you will find the link to this web page in the description below. You can check it out in the description. From the description, when you scroll down, you will see a fee of 0 rupees. So earlier, like if you can see the price, earlier it was being offered for rupees 5,499, but right now this is free of cost. So like to register in this course, in this crash course, you just need to click on buy now. You will be asked to fill in your mobile number and some other basic details. And this crash course will actually benefit you very much, because this will be a single source wherein you will get all your digital study material, all your assignments, class notes, all India test series, all the classes, the schedule of all the classes which are being conducted in this crash course. So all in all, it's a very good opportunity for you, and right now it is being offered just for free, just for 0 rupees of fees, right? So do make sure to check this out from the description below. You will find the link in the description. In case you are facing any difficulties to register for the crash course, you can just post in your problems with the in the chat section or in the comment section. Okay, so coming back to our chapter, we are going to continue current electricity from where we left off yesterday, right? So yesterday we discussed about the basic, what do you mean by current, the basic things like what do you mean by current. Then we discussed the formula. And then after current, we discussed Ohm's law, resistance, current density, conductance, conductivity, drift velocity, relation between current and drift velocity. The formula was I is equal to NEAVD. Then we discussed temperature dependence of resistivity for metal, semiconductor, electrolyte. Then we discussed about ohmic and non-ohmic conductors and what is the basic difference between them. And the last topic which we were discussing yesterday was your EMF. Like, what do we mean by EMF? What is the difference between EMF and terminal potential difference? And we started discussing grouping of cells, right? So we'll be continuing from here today, and we'll also be doing some practice questions. So for today's class, like for the first 30 minutes, we'll complete the remaining chapter, we'll complete the revision of the remaining chapter, and for the later 30 minutes of the class, we'll be doing some PYQ questions, right? So this was something which we are discussing. In grouping of cells, primarily, what two things we'll discuss. First, if the cells are in series, and second, if the cells are connected in parallel. And the third grouping was mixed grouping. So in series, as we studied for resistors, we have a cell, we have its internal resistance. Then we have other cell, we have its internal resistance. What will be the net EMF and the net resistance of both of these batteries? So if I say E1 is the EMF of first battery, E2 is the EMF of second, R1 is the resistance of this, R2 is the resistance of internal resistance of the second battery, second cell. So the net EMF, the formula was simply the sum of individual EMFs, E1 plus E2. This will be your net EMF, and the net resistance will be R1 plus R2. The same formula for resistance in series, right? This will be your total resistance. Basically, when we are saying this will be your total resistance, means you can just replace these four things with only just simple two things. This will be your total EMF, this will be equal to E1 plus E2, and this will be your total resistance R, this will be equal to R1 plus R2, right? So this is the meaning of grouping and equivalent, right? And when we were saying that if the cells are connected in parallel, so this is your first cell, this is your second cell, and like this they are connected in series, then in parallel, sorry. Then what will happen? This is the EMF E1, this is R1, this is E2, this is R2, right? So over here in parallel, what will be the net EMF and the net resistance? We are supposed to calculate that. So for net EMF, our formula was E1 R2 plus E2 R1 by R1 plus R2. Basically, the EMF of first cell multiplied by internal resistance of second plus EMF of second multiplied by first resistance of first divided by R1 plus R2. And the equivalent resistance was, the formula for equivalent resistance was same as is the formula for resistor in parallel, R1 R2 by R1 plus R2. This is the same formula which you will get from here. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Once you simplify, you will get the same formula. Okay, this was for series and parallel. Then the third thing was mixed grouping. So in mixed grouping, what we discussed what you people must have studied is, like, you have n number of cells, this n number of cells in series, and each cell have some amount of internal resistance as well along with it, right? So there are n such cells, and the EMF of every cell is E, the resistance of every cell is R, and you have m such rows. You have m such rows. We'll say we have m such rows, right? So what will be the total EMF and total internal resistance in mixed grouping? Mixed grouping means some cells are in series and then some are in parallel. So what we have to do is we have to solve it. In simple two-step manner. What will be the two-step manner now? Like, you have n number of cells in series and EMF of each cell is E. For series, we have just discussed. That net EMF will be the sum of individual EMF, right? So the total EMF will now become n times of E. The total resistance will now becomes n times of R. If I say this is equivalent EMF, this is equivalent resistance. Total EMF is just multiply n times of single EMF and total resistance is just n times of single resistance. And we have m such rows. That means we'll get m such combinations, right? So this is again E equivalent NE and R equivalent NR. We have m such rows. And in parallel, we just discuss the formula. If you put in this same scenario in this formula, within this formula, it becomes ER plus ER divided by 2R. This is 2ER by 2R. 2 gets cancelled by 2. R gets cancelled by R. Only E is left. So basically, if the EMF of one cell is E and m such cells are connected in parallel, then the total EMF will only be E, right? And in mixed grouping, so we mainly were supposed to remember two formulas. First, for the total current. Total current came out to be MNE upon MR plus NR. M is the number of rows, N is the number of cells in one row. R is the internal resistance. R is the external resistance. Capital R is the external resistance. So it is just connected over here along with the battery, right? Like this. So this was the formula for current. And then there was one condition that you have to maximize this current. We have to find out a condition, the relation between internal resistance, the relation between small r and capital R, such that current is maximum. So if we want to maximize this current, in that particular scenario, we have to minimize this denominator. If the denominator is minimum, current will be, if the denominator is minimum, current will be maximum, right? We need to maximize the current. To maximize the current, then I'm saying we have to minimize it. If we have to minimize it, then there was a, we just followed a trick. We can write it as under root of mr whole square plus under root of nr whole square, and then we can open it using, like, you can see it as a square plus b square. So you can just simplify it using, I'll do this on the next page. So we have root mr square plus root n r square, sorry, m capital R and n small r. We have m small r plus m capital R plus n small r in under root, right? This was the denominator. The denominator was mr plus nr, and we have to minimize this denominator. So what we are trying to do is, we are trying to, like, write it in a different manner so as to minimize it. So you can just see it as a square plus b square. Then a square plus b square you can write as a plus b whole square minus 2ab. So we'll do the same thing. We have this expression. Now we can write it as root of mr plus root of nr whole square minus 2 root mr and root nr. Now what is the benefit which I get over here? The benefit which I get over here is I have a term for this. I have a whole square. Now whole square can never be negative. So what I have to do, I can just equate it to 0. When I equate it to 0, then in that case I can write capital R will be equal to n times of R upon M. So this was my capital R, the relation between external resistance and internal resistance. You have already studied this for your 12th class exam, right? This was the relation. For this relation, current will be maximum, right? So even if you don't follow the process, even if you're not able to understand the process, I just revise the process for you. But in case you're not able to memorize the process, you just need to memorize this formula, at least for your NEET exam, right? So this was for maximizing the current. Now moving forward, the next topic was your heating effect. In heating effect, what we discussed was, you've also studied this in your class 10th. Whenever a current will flow through some resistance of resistor, resistor of resistance R, whenever or wherever current will flow through the wire, through any resistor, it will always dissipate a heat. It will always release some heat. And that amount of heating will be equal to, the formula for calculating the heat energy was I square RT. I was the current, R was the resistance, and T was the time for which current is allowed to flow through the wire, right? And this statement, like this equation, was given by Joule's. This was called Joule's law of heating. So for calculating the heat energy, or calculating the, simply I can say energy, formula was I square RT. And from here only we got three formulas for power. So power is basically work done per unit time. Work done is equal to energy. So work done is I square RT divided by T. T gets cancelled with T. Power comes out to be I square R. Now using Ohm's law, Ohm's law was V is equal to IR. I can substitute I in terms of V by R. When I substitute I by V upon R, it becomes V square by R square. V square by R square into R. So 1 R gets cancelled with square. V square by R. Then I can also write V as, or I can write R as V upon I. If I put in this formula R as V upon I square into V upon I, 1 I gets cancelled with square. So we get three formulas for power. I square R, V into I, or V square by R. All these three formulas are used for calculating the power consumed by any resistor. And if we multiply this power with time, we will get energy or heat. So for energy, again, we have three formulas: I square RT, VIT, or V square by R into T. These are the three formulas for energy. So this is the basic heating effect, and then in heating effect you also get the questions for calculating the commercial, like if when you're consuming commercial unit. So commercial unit of power consumption is, or energy consumption is, kilowatt hour. Kilowatt hour basically means when you are calculating the energy, you have to take the power in kilowatt and your time in hours. Then you will get the energy in kilowatt hour, and 1 kilowatt hour is the commercial unit. This is called commercial unit of energy consumption. So in questions, what you are usually given is, you will be given that the cost of 1 unit of electricity, or the cost of 1 unit of energy is 2 rupees, 8 rupees, 10 rupees, and then you have to calculate the monthly bill of a household. Now, like you can be given that you have a power, you have a bulb, and the resistance of that bulb is maybe take 10 ohm. You have a bulb, the resistance of that bulb is 10 ohm, and the current required by that bulb is 2 ampere, and you are using this bulb for 1 hour every day. In one day you use it for 1 hour, and you have to calculate what will be the total bill in 30 days if every day you use this bulb for 1 hour at the rate. The cost for electricity basically is 10 rupees 10 per unit. So what steps should be followed for these type of questions? First, you can calculate the energy consumed in one day. We have I, we have R, and we have T. You can just use this formula I square RT. I square RT, when I use 2 into 10, 20, 20 into 1, 20, right? 20 into 1 is 20. But the problem is when you are calculating using directly ohms and ampere, you are getting the power in watts. You have to convert the power from watt to kilowatt. 1 watt is equal to 1 upon 1000 kilowatt, or you can just remember 1 kilowatt is equal to 1000 watts. So make sure you convert the power in kilowatts. Time is usually given in hours. You just have to make sure of two things: first, your power is in kilowatts; second, your time is in hours. When you have power in kilowatts and time in hours, you will get the energy in kilowatt hour. You will always be given cost for 1 unit. 1 unit means 1 kilowatt hour. When you keep power in kilowatt, time in hours, then you will always and always get the energy in kilowatt hour, and you just simply have to multiply it with the cost and you will get the answer. So we'll do these type of questions today in the class later on. Now the two most important topics of this chapter. First is KCL, second is KVL, Kirchhoff's voltage law and Kirchhoff's current law. So current law, it basically states that for a junction, if at a junction, this is a junction, let us suppose 4 wires are coming. 2 wires are bringing current into this junction, this I1 and I2, and these 2 wires are taking the current out of this junction, right? I3 and I4. Then junction rule states that the total input current should be equal to total output current. Input current, the current which is coming inside the junction, is I1 plus I2. The total current going out of the junction is I3 plus I4. KCL states that in a junction, the total input current should be equal to the total output current. So I1 plus I2 should be equal to I3 plus I4. Simple. So you just have to remember one thing, that whatever quantity comes in, that same quantity has to go out. No wastage is happening in between, and no addition is also happening in between. Like we are not supplying some extra current in between to the junction, or we are not taking something out of the junction. Basically everything is conserved. So KCL was basically a consequence of or you can say it is mainly based on the law of conservation of charge. Why law of conservation of charge? Because when we are talking about current is basically charge flowing per unit time. So we are basically trying to say the amount of charge which junction receives, the amount of charge entering the junction will always be equal to the amount of charge moving out of the junction, right? This was KCL. Then KVL was the loop rule. The KCL name of KCL was also junction rule. Name for KVL was loop rule. If you are given a loop, like I simply have a resistor capital R, then I have a battery and I have a cell and I have a internal resistance of this cell. This is plus, this is minus, and this current is being supplied in this loop. Then what does loop rule states? Loop rule states that if you move across a loop in a circuit, like I start from this point A, I move like this in the circuit. When I come back to A, the net potential difference should be 0. The sum of net potential should be 0. So when I start, for loop rule, you just have to remember two things. Like if you have more than one loop, like most of the questions you are given more than one loop, you have to traverse the loop in the same direction, all the loops. Like either you have to traverse the loop in anti-clockwise direction or clockwise. It should not be the case that you are going or traversing one loop in clockwise and the other in anti-clockwise. Then you will get the wrong answer. So if I move clockwise in this loop, I just have to start from this point. The second main point which you have to remember is that whenever you see a resistor, always remember that in a resistor, the current always flows from positive to negative. You will never ever do a mistake in sign, in keeping the sign. So what you have to remember, whatever sign you encounter when you are moving across the circuit, whatever sign you see first, you just have to write that sign in front of the potential. Potential across a resistor is I into R. And first I encounter, when I am moving from here to here, first I encounter a positive sign. So the potential will be plus IR across this resistor. Then I come from here, I move here, now I encounter this resistor. Current is flowing in this direction only. Current will always flow from positive to negative. Again, I encounter positive sign first. So I'll write plus IR. Then when I cross this internal resistor, first I encounter the negative terminal of the cell. So when I am writing the EMF of the cell, I will write it with a negative sign. And this whole thing will be equal to 0. Basically, what you have to remember is whatever sign you encounter first, be it positive or be it negative, you just have to simply write that same sign. If it's positive, you have to write positive. If it's negative, then you have to write negative. Okay. So this was KVL. This was basically the loop rule. If you have any doubts, you can just post your doubts in the comment section below. In case you don't have any doubts, then we're just going to do a small discussion on Metre Bridge, and then we'll be moving to the questions, practicing the PYQs. So Metre Bridge, so what happens in a Metre Bridge is basically you have this 1 meter long wire which is arranged in this sort of a format on a board. So why is it named Metre Bridge? Because it consists of a wire of 1 meter, right? What happens is like the wire practically, if you have seen in your school or anywhere where you have done practicals, practically the wire is arranged in this format because it is a longer wire. When we draw it theoretically, we just draw a simple plain wire, and along with this wire you have two resistors which are connected, and along with this you have a stylus. मतलब stylus is basically like a metal shaped, like you have seen an electrode, not exactly an electrode, it is basically like I have this pen through which from which I am writing. So you just have a stylus, and what we do is we start from the zero end and we move the stylus across the wire. You start moving the wire across stylus from this 0 point. You have a scale fixed over here to take the reading. This is 0 point and this is 100 centimeter. It is a 1 meter wire, so 100 centimeter. What you do is you have a stylus in between. You have this stylus connected in between, and this stylus is connected with a galvanometer. So what we do is we start moving this stylus. I'll use some other color. We'll start moving this stylus from this zero level, and the galvanometer, which is connected over here in this stylus, will stop at that point in which at the point at which the deflection in galvanometer becomes zero. Galvanometer is basically a device which is used to detect current, like if whether the current is flowing or not. So what we do, we start moving the stylus from this 0 centimeter point. We will keep it moving. You will keep moving it. For example, if at this particular point you see that the galvanometer needle has stopped deflecting, or it is just like it has rested in at a 0 point, you will just stop at this point, and we call this point as null point. Why do we call this point as null point? What we'll do, for example, if the reading over here is 40 on the scale, this means at 40 centimeter you have got a null point. Null point means the total current flowing through the circuit is zero. You must have studied something called a Wheatstone Bridge. So Wheatstone Bridge is basically a this sort of a setup wherein a galvanometer is connected in between. You have four resistors connected like this, right? And this is the battery. This is R1, this is R2, let us suppose this is R3, this is R4. So there is a balancing condition in a Wheatstone bridge. Balancing condition states that whenever the ratio of R1 by R2 is equal to ratio of R3 by R4, no current will flow through this galvanometer. The current flowing through this galvanometer will be zero, and we can simply remove this arm from the circuit. This was a balancing condition. So meter bridge works on this principle, this same principle. This is a null point. Null point is basically the point at which we got a balance point. Balance point means at which the Wheatstone bridge is balanced, or at which the current flowing through the galvanometer stops. Now, how do we get four? How do we see four resistance? So two resistors I can simply see in the circuit. The other two resistors are basically this wire on which you were moving the stylus. So this wire has some length. This length came out to be 40 for me, right? If this, or if I simply say this wire is L, then the remaining length of the wire is 100 minus L. Every wire has a resistance, and the resistance of every wire, this is the same wire, so resistivity is same. Formula for resistance is rho L by A. I am considering the same wire, like I am just taking two parts of the same wire. The only difference between two parts is their length. Their area is same, their area of cross section is same, their resistivity is same, because this wire is made with same material, right? So when I say if the length of this wire is L, then its resistance will be rho L by A. If the length of this wire is 100 minus L, then its resistance will be rho 100 minus L by A, right? I am saying if you look at this wire like R1, if you look at this resistor like R2, you look at this wire of 100 minus L length as R3, and you look at this as R4, right? And now if you take the ratio, L upon R2 is equal to 100 minus L upon R4. Why did not I write rho and A? If you write, you can do that, not a worry, but that will get cancelled out. You can see rho by A, rho by A, rho by A gets cancelled with rho by A. Now I can transpose and I can simply say L upon 100 minus L is equal to R2 by R4. So where do we use this meter bridge? You will already know a value for R2 or R4. Like either of these two resistors, you will know the value of one. Like if you are given that R2, the value of R2 is 20 ohms. And then you go to the lab and you have to find out the resistance for R4. Then what you will do, you will connect R4 over here from the resistance box, and then you simply start moving the stylus. You simply start moving the stylus. As soon as you get a null point, you get the value for L, and then you put the value of L and 100 minus L, and you get the R4. So I have a doubt. What about the wire on which other two resistors are attached? So basically what happens is like, I'll just use another slide. So I think you are asking about, like, one wire is this on which we are moving the stylus, and you are saying, like, you're talking about this wire through which the other two resistors are connected, right? So the thing is, the wire which we use over here on which we are moving the stylus, this is a comparatively thicker wire, and this wire is a very good conductor. So like, it has a good amount of resistance, like it is comparatively thicker. And the wires which are used over here for making the connections with the resistors, those wire are comparatively very thin, because this wire is very thin and this wire is comparatively thicker. So like, a thicker wire, and this is also made with some other material which has a good amount of resistance. So these wires which are actually used for making the connections, we can just simply ignore the resistance of these wires. Like in this case over here, we have two resistors connected. This is a galvanometer and this is a stylus. If I get the balance point here, so this is a appreciable amount of resistance, this wire R1, this is R2, this is R3, and this is R4. Like, the only difference between the two wires is the wire on which we move the stylus, that comparatively has a appreciable amount of resistance, and the wires which we use for making the connections, those wires have a comparatively lesser resistance, like a negligible amount of resistance. I hope your doubt is clear. So this was about meter bridge, and then you also have a device called potentiometer. So we have we simply use potentiometer for calculating an unknown EMF. Potentiometer, it basically works on the principle of potential gradient. So basically, the potentiometer, in potentiometer, what we say, we get the relation between V is equal to KL. Like, I'm just explaining it in short, so we have a good amount of time to practice the questions. So potential gradient is basically potential per unit length, and you say that potential gradient is a constant. Potential gradient is a constant across a potentiometer wire, and then this constant K is called the sensitivity of the potentiometer. And then like, for the potentiometer as well, we have a same sort of thing. We have a jockey, we move that jockey across the wire, and as soon as we get the null point, we just use the potential gradient formula. So simply, if I tell you, like, when you have to calculate the unknown EMF, over there the formula comes out to be E2 by E1 upon L2 by L1. You will be given the value of either of the EMF, either E1 or E2. You get the null point, the length L1 and L2, and then you can find out the fourth variable. And you can also use the potentiometer for calculating the internal resistance of any cell. So I've just discussed both these devices in very short. Like, there is a lot to explain within these devices, and how do they work, what principle do they work on. In case you have any doubts in these devices specifically, or any other topic of this chapter, because this is supposed to be a one-shot video and a quick revision sort of a video, so we are doing it quickly. If you have any doubts in any topics, or if you want us to, if you want me to cover any particular topic within this chapter or from any other chapter, you can just post that in the comments, and I will surely take that up in any next video. Okay, so this is all about the revision of this chapter. Now we'll be moving to the questions. So before moving to the questions, you can already see we already solved the first 10 questions of these slides in our yesterday's session. If you have missed the yesterday's session, you can just watch the recording. So these are all these questions are PYQs. You can see the year at the bottom. Like, this is a 2015 question. Before starting the questions, there is another initiative which is being run by us, which is being run by Vedantu. So this is something called Vedantu NEET AITS 180 test series. This is a test series. You can check out this test series also. We have posted the link in the description below. What benefit you will get from this test series, especially for your Re-NEET examination? It is designed by experts. So like, there is a maximum, there is a very good possibility that maximum questions might come from here only. Within this test series, you will get 3600 plus MCQs, 12 full and 8 part syllabus mock test. So you'll get a good practice of questions. So do make sure to check out this AITS, and also, like I talked about in the start of the session, also do make sure to check out our crash course. The crash course is being offered just for free. Now coming back to the questions. So what we usually do, what I usually do in our classes for any new students who have joined us today, you will get 1 minute for each question, and then you have to type in your answer in the chat section. And after 1 minute, we'll discuss the question. So your 1 minute starts now. You just need to post your answers in the chat. Like you can just post in the option, like out of A, B, C, D, which option do you feel is the correct answer? You're just asked that, like this is a very relatively very simple question. You're just asked, okay, on what factor does the resistivity of a conductor depend? So just to reiterate or revise, in your yesterday's session we discussed resistance is a property of a conductor and resistivity is the property of a material. So any answers, if anyone can post in the chat, out of A, B, C, D, or do you feel should be the correct answer for this question? Any answers? You know, I always say this to all my students that you should never ever fear answering in the class, because all of these things are being done for you only. The answer may be wrong, not a issue. Like your answer might be wrong, not, there is no problem with that. But at least you should answer the question. Only then, at least you should solve. Only then you will be able to understand your mistake. Like where are you committing the mistake? Okay, so now we'll discuss the answer. You're saying the question is saying you have to find tell on what factors does the resistivity depend. So as I told you, resistance, the formula for resistance is rho L by A. Resistance is the property of a conductor. Resistance depends on length and area, but resistivity is the property of material. Resistivity will only depend on the material. And yesterday we saw the temperature dependence of resistivity. Like for metals, along with the increase in temperature, resistivity was also increasing. For semiconductor and electrolyte, it was an inverse relationship. That means resistivity is only depending on two factors. First, the nature or type of material. Second, the temperature of the conductor. So the correct answer should be C. The correct answer should be option number C. Moving forward to question number 12. So this is a good question. This is, you can see this question came in 2020 exam. Like you can just mark this important. You're given a wire of resistance R. It is cut into 4 equal pieces and then joined in parallel. You have to find out the equivalent resistance. So guys, quickly, like you have to quickly answer this question. You have to just write the correct option. Quickly solve this and post your answer in the chat. Just remember, when you are dividing a resistance, a wire, in equal parts, the resistance will always be divided equally. Like in these type of questions, you have to consider except the length. When we are cutting the wire, except the length, nothing else is changing. So like just a hint for you people, if a wire is cut into 4 parts, then the total resistance of the wire was R. For one piece, the resistance will be R by 4. And then you are connecting all these 4 pieces in parallel. So basically, you have R by 4, R by 4, R by 4, R by 4 in parallel. You are asked to find out, so the question is saying wire has resistance capital R cut into 4 equal pieces. Equal pieces R by 4, R by 4, R by 4, R by 4. And then they are joined in parallel. You're not asked the question, you're not asked the resistance of one piece. You are now asked that after connecting these pieces in parallel, what should be the equivalent resistance? Equivalent means R by 4, R by 4, R by 4, R by 4. You have to join in parallel. So what should be the answer then in this case? Yesterday I also shared a short trick, a shortcut. The shortcut was like equal if I have two resistors, each resistor has resistance R connected in series. The total resistance will be 2R, R plus R. Now I generalize this thing. If I have n such resistors, then my resistance becomes n times of R in series. Similar case, if my resistance of each resistor is capital R and I have again n such resistors connected in parallel, then in parallel the total resistance becomes R by n. Like for competitive exams, you should remember the short tricks, the shortcuts, the short formulas. So the formula for parallel becomes R by n. One resistor is R by 4 and I have 4 such resistors. So R by 4 divided by 4. The resistance now becomes R by 16. If you are not able to memorize the shortcut, then what you have to do, if you are not able to memorize the formula, you can just simply use the longer method. 1 by R is 4 by R plus 4 by R plus 4 by R and plus 4 by R, the reciprocal of resistance. So this becomes 16 by R and this is equivalent resistance. It becomes reciprocal R by 16, option number C. I hope this is clear. Moving forward to next question. So in next question, you are said you have a uniform wire of resistance 20 ohm. It is stretched. So yesterday also we did a similar question. Whenever the wire is stretched, length and area both will change. You just need to, you can just keep these short tips and tricks. Like whenever you see a particular word, you have to just remember these things. You can just write these things in your formula notebook. Both will change. Both change whenever we use the word stretched. Whenever you use the word cut, cutting means only length will change. Area won't. Only length will change. Area will not change in case we are cutting the wire. If you are stretching it, and the change in length and area will be similar. Like if the length becomes double, area will become half. The amount of times the length increases, the same amount of times the area decreases. So you are asked to find out the earlier resistance of the wire was 20 ohm. Now it is stretched and its length becomes doubled. What should be the answer? Okay, then we'll discuss this. So earlier the resistance was rho L by A. Now the new resistance, if I call it R dash, now it becomes rho into 2L divided by, now we are saying stretched. After stretching, the length is doubled. If the length is doubled, if length earlier was L, now it's 2L and we are stretching it. So why does the area change? Because the volume will remain constant. So now in this case, area will become A by 2 because the length has doubled. So A by 2, this 2 goes in the numerator. So total resistance becomes 4L by A, right? The value of earlier resistance was 20 ohm. Basically, rho L by A was equal to 20 ohm. Then 4 rho L by A should be equal to 4 into 20, right? 4 rho L by A will be 4 into 20. So answer will be option number C, 80 ohms. This was a 2012 question. This question came in 2012. Moving forward to the next question, question number 14. Question number 14, now it's saying you have two wires of same material. Same material means their resistivity will be same. Rho will be same. Their lengths are given, the ratio of their lengths are given 1:2